Much, first of all, for joining the webinar. We welcome you to this. And as you know, the topic for today would be about design patterns for Salesforce app decomposition using the second generation packaging that Salesforce is developing, or 2GP as it's called. So let me introduce the speakers for today. My name is Abhilash Murali. I am a senior customer success engineer here at AutoRABIT. And I'm also joined here by Prashant Sundrella. He is the practice architect within our customer success division. And also on the screen, we do have our Twitter handle. So if you ever want to reach out to us or have any questions that we don't get to answer in today's session, by all means, shoot us a message on Twitter and we'd be more than happy to answer them. And as far as the Q&A is concerned, we will have ample time towards the end of the session in order to answer some of the questions that you have. Feel free to use the chat in order to input your questions, and we'll make sure we get to them as quick as we can. So before we get started, our forward-looking statement. So please make sure that you do your own due diligence and your research to make your purchasing decisions, and make your purchasing decisions based off of the current offerings that we have, not based upon any future or beta offerings. So let's go over the agenda for today. So to start off, we'll be talking about the traditional software design patterns. So your current process with your org-centric model, with developer sandboxes, with using version control, and using more an org difference-based approach and a component-based approach. And from there, we'll tie that together with how the traditional model currently works into the new 2GP or second generation packaging that Salesforce is offering. We'll talk about the different schema offerings that there are in terms of database or business logic, and what are the specific metadata components that those particular sets comprise of. We'll also move on into more of the modular development. So it's great that there's second generation packaging, but how does this work? How do I make sure that I create packages successfully? How do I move it across the different stages? How do I commit to version control? How do I ultimately release this into production? So we will talk about that. And lastly, we'll talk about what AutoRABIT has to offer in terms of our Salesforce DX integration, along with some of the new features that we do have to offer. And now with that being said, to kick this off, what I will do is pass this off to Prashant to continue on and speak a little bit about the different design patterns that we do have within AutoRABIT and Salesforce DX, and speak a little bit more to how the 2GP framework works. So Prashant, go ahead.
Thank you very much, Abhilash. That was a very kind introduction. So Salesforce is going through a transformational journey in terms of taking its platform from a more monolithic code database, from a monolithic code base into a platform where it is on par with the traditional software languages of the world, like a Java or a .NET or a C#. So what are design patterns? So when you approach design patterns in Salesforce, there are two different meanings. So one is the design patterns that would be useful for creating your modular components. So for example, if you're developing an app, the app will need to have some custom code in it, which will have some Apex classes, some Visualforce pages in order to showcase the features that you're trying to put out in your application. So design patterns will come in two forms. One, the form in which we develop the application, the engineering that goes behind the design pattern. Two is the pattern in which you would be able to package your metadata component so that it could be delivered to your higher environment, say a integration environment or a QA environment, in a much faster approach. And this is what Salesforce is solving, and I think it has already solved it in terms of providing the much needed interface. So when you hit design patterns, the first thing that you come across is when you get a user story as part of a development, these are some of the things that you will come across. So you'll have a problem statement, you'll think of the consequences, what are the context, what are the benefits, what is the namespace that should I be using, would there be any dependencies? So all of this will constitute to what on how you would be approaching the problem. So design pattern in its definition is to have a reusable solution to some of the common problems. It's never a finished entity. It's about finding that trade-off that gives you the perfect balance between having a clean modular design and not going overboard with it so that it becomes impossible to achieve. So that being said, it also gives you greater maintainability, makes app development easier. It makes it makes things more organized, and lets developer and kind of puts developers on the highest edge of productivity. So talking about design patterns, these are the traditional design patterns available in the software engineering right now. There are many design patterns, but of all of them, these are the four. You can, from a hierarchy perspective, you can group them into these four categories. One is creational, where a pattern is used to construct objects such that they can be decoupled from their implementing system. For example, if you have a class, how do you go about in creating subclasses so that you make sure that from a application design, you're able to compile those classes faster and you're able to produce outputs faster. Behavioral is a pattern where you are kind of initializing complex object structures between disparate objects. You also have a structural, which is the most commonly used between structural and concurrency. The new age algorithms, relationships, responsibilities between objects managed through event behaviors. Like, for example, you do a click event action on your application. What are the 1, 2, and 3 things that will happen based on the relationship database that you have or the class hierarchy structure that you have? And the most commonly used in the modern application development is concurrency, in order to have a design thought where you would be able to create a architecture where, for example, a leader-follower architecture where you one event will direct the output of multiple other listeners. So you have like a worker bee structure where the action is initiated by the queen, and the worker bees will complete its job and come back to the queen with the output. So multiple things that happen in design patterns. So how does this apply to Salesforce? So from a design pattern thinking, Salesforce has put out something called as Apex design patterns, which is pretty useful in terms of understanding how you can use these patterning on the Salesforce.com platform. For example, you have the singleton, strategy, decorator, composite, or bulk state transition. So multiple design patterns. I would ask the audience to kind of check the Apex design patterns that is put out by Salesforce. It is wonderful. Now, when it comes to the Salesforce application schema, this is how we would envision the application schema. So you have your schema logic. The schema logic is where you have your standard objects, your custom objects, or your sales cloud or your service cloud. And on top of that, you have the utility layer or the domain logic where your triggers, your Apex classes, your Lightning components will flow through. And if you have any kind of web service integrations, that would be the logic on top of it. So based on these 3 pillars, you would be building the features on top of your application. So say, for example, you have a timesheet application. The timesheet application would be tracking expenses, the time spent by each of your employees, what project that they have spent the time on, et cetera, and et cetera. So if you consider timesheets as an application with 1, 2, 3 features, what are the couple of things that you need to do in order to build that logic inside of Salesforce so that you would be able to create patterns around it? So that being said, the second type of packaging would be the application packaging model, and that's what we're going to be talking about more in terms of how do you use the new generation of second generation packaging that is provided by Salesforce. Now, second generation packaging, there are 2 flavors to it. One is the developer controlled packages, where developers would be responsible for the creation of the package and the delivery of the package. And the second flavor is for the ISVs. It's just called 2GP, where ISVs would be able to create managed packages. Just similar to the managed packages, they would be using the second generation, using the DX CLI or the DX interface in order to create those managed packages. So any application will have these 4 concrete composites. One is a database. The database, from a declarative standpoint, will contain custom objects, fields, relationships, your standard objects. In terms of manipulating the database, you will have your Apex triggers in terms of the coding. The next axis, or the next composite layer, would be the data axis. How do you perform your data manipulation language, or your inserts or upserts on top of the database? So it could be done declaratively using data loader. From a coding perspective, it could be done by your SOQL queries or your SOSL queries, or the general Salesforce APIs in terms of the SOAP API, the tooling API, or the metadata API. The next composite layer is your business logic. In terms of based on a particular requirement, how do you make sure that your user interacts in a certain form? It could be your formulas, your validation rules, workflow rules, sharing rules, and in coding, it is your regular Apex, where you'd be able to direct a user or channel a user through a bunch of features using the Apex coding. And it all comes down together on a user interface. So the user interface would be your layouts, your record types, formulas, reports, lightning interfaces, dashboards, or visual force pages as well. So these are the 4 composite layers in which your application would decompose into. So from a developer perspective, if you are thinking of moving to a package-based development and deployment model, then you would have to start figuring out how do you split your application logic into these 4 composite layers. Now, you can also have additional composite layers where your UI would also be performing some sort of business logic actions. So this is the materialized path that we have kind of envisioned for the second generation packaging. So in terms of understanding how you need to decompose, or what are some of the patterns that you need to look for in your applications when you are thinking of moving into a package development mode, is one, you need to look for applications that are built inside of your Salesforce environment, anything that has been developed right from the custom objects, right from your custom code, your workflow rules on those custom objects, everything that has been developed in-house on the application can be one pattern that you can identify in order to start decomposing your monolithic code base into packages. That will also include new development. Anything that extends the standard Salesforce functionality in terms of the Sales Cloud or the Service Cloud, if you've created any sort of customization, and most enterprises do create customization that will fit their domain. So anything that extends the standard functionality of Salesforce, that could essentially form one sort of pattern for identifying your packaging. The third thing is any customization that you have done on your App Exchange packages like Steelbrick or Conga, or Squid packages. So if you have created any sort of unpackaged components on top of these managed packages, they can also form a kind of a base package. So when you install your App Exchange package, you can simply move this additional packaging that you have created on top of the App Exchange to an environment which will together form your application. Any sort of newly created metadata that could include Lightning pages, Apex classes, or anything that is being done in-house is the mantra that you need to follow. And stories that can be released independently. So you'll have to work with your ALM system in order to understand if a particular story would fit the bill. And how do I go about in creating my base by understanding how the 4 composite layers that we spoke about a little earlier ago, and how do we split them into logical chunks. So the mantra that you need to follow for packaging is make sure that you have atomicity, consistency, make sure the components are isolated, and you have durability on top of those components. Some of the things that you should not be doing or that you should be watching out for is it can never be a possibility that your entire Salesforce org, your enterprise org that you are having for the last 5 or 6 years can form into a singular project. It can never happen. So that is the trade-off that you need to do in order to find cleaner modular design so that you're not going overboard. you need to avoid cross-component references as much as possible. Keep the code cleaner with a few coding patterns only. Favor immutability, which is again the fewer code in terms of avoiding the cross-component references. Make sure that you're able to consistently achieve this. For example, if you have created a base package for your application, and your base package also has some shared schema on your Salesforce org, which we generally do. For example, you have the account, contact, and opportunity with products, which are a couple of objects which constitute the main base layer of any major application. So how do you identify this base package, and how do you consistently evolve this base package so that you're moving to a place where this base package can be inserted into a scratch org, and the developer can work on top of this base package in order to create a new package, which will essentially form the version 2.0 or 3.0 of an application. So watching out for shared schema and decompose apps based on it. Watch out for standard objects, which are heavily shared. Add and keep adding shared objects to your common schema, and this is how you would evolve. This will not happen in a day. Salesforce themselves are predicting a timeline of 6 months to about a year before the whole Salesforce monolithic code base can be transformed into a package-based structure. So those are some of the patterns and anti-patterns that you will need to identify in order to figure out your happy soup or your migration recipe. So before the inception of the second generation packaging, and if an enterprise is using version control, so normally developers would use their sandboxes, their individual sandboxes, or their grouped sandbox where multiple developers are working on the same sandbox in order to pull and push from the version control, in order to push their metadata members that they have developed by code or by declaratively into the version control. And the same thing is sent into the integration environments or the QA environments directly from the version control. So here, you're not using any kind of modules, you're not using any kind of packaging, you're using the standard metadata API in order to create your package manifest, identify what are the members that needs to be moved from one environment or from one release to another release. So basically what you'd be doing is you'd be figuring out what are the org differences, and org differences are always tracked manually. The org differences need to be always version controlled. So you will never be, you'll only be working on the delta that needs to be moved into the production org as part of the release. So for example, if you have an application, you'll figure out what is the X amount of effort or the X amount of code or configuration that I need to generate in order to move, in order to make sure that my user story gets promoted into the production org as part of the release. Now, when this promotion happens, the developer would not be pushing the entire app by itself, but he will only be pushing the delta of the change that he has made in order to complete his user story into the production. And again, as I said, all phases of this development process are executed manually by the metadata API. Releases are specific to a production org, but they're never specific to an integration. So you cannot have parallel lines of development. And if you're trying to do parallel lines of development, like many enterprises are doing right now, you'll have to adopt an agile methodology where you're making sure that the developers are not stepping on each other's toes. You're moving each revision number from your version control independently without any dependency. So it kind of creates a lot of overhead, leads to a lot of deployment problems, and makes the tracking between your ALM system where your user story resides to the code that resides in your source control system to what's getting delivered in the Salesforce org. So there's no one singular interface where you can see that, okay, this is my user story. These are the metadata members that are part of this user story. This is where it was committed. This is where it was merged. This is where it was deployed. So there's no one place to see it right now. And this makes it very difficult to have an agile methodology around a Salesforce delivery. So that is the reason why they come up with the packaging model, where packages can be independently created and independently pushed into multiple orgs without any dependencies on the previously deployed packages. So a package is either installed or upgraded depending upon the version that you're trying to push. So with the DX way, ISVs like AutoRABIT are pretty happy that Salesforce has come out with this sort of structure, which allows source-driven development, collaboration of development teams, flexible packaging model, which is nothing but the containers for transporting modules of your metadata, adding, editing, removing components on the fly. So for example, as part of a user story, you needed to push 2 custom fields and 3 workflow rules. But it was later realized that one of the workflow rules has been turned down by business. So you can simply remove that workflow rule and create a new version of your package, and your package is ready, instead of going back to your version control, reverting the change, and creating your package from scratch. So at all point of time, metadata and code are modular. Environments can be easily created and disposable for which is nothing but the scratch orgs, where you can create empty orgs that can shape up to the requirements that you have based on your preferences or the feature set that you want from Salesforce, and you put your development on top of it. And releases schedule for each package and not for a sprint, or it could be a part of a sprint, but essentially in a sprint itself, you'll be moving an X amount of packages. And instead of talking about what is the metadata members that have been moved, you'd be talking in terms of artifacts. That opens the door for adopting a more traditional software development lifecycle where artifacts are promoted and not code. So for example, if you have a Java app, you will not promote a class, you will promote an entire application as such into the next version. So post the 2GP, as I was saying, so scratch orgs would be used by the version control in order to create your packaging. I'm sorry, the legend text here should say push and pull, source push and pull. From the version control, packages are sent directly to your environments to let it be integration, QA, UAT, or prod. So there's nothing coming back to the version control. Everything would be driven in entirety by the source itself. So developers would be working in the scratch orgs, making sure that they have all the base packages or the base metadata that you need in order to develop a package. Now, we will talk more about how do you develop this base package. So for example, I have an application, a user story that requires 10 custom fields and 10 Apex classes to come into my scratch org, but I'm not sure what are the other dependencies that I have in order to make sure that I have this base package in my mind. And that's where AutoRABIT has created solutions to help the Salesforce development community to take it further. So let's go exploring the AutoRABIT.
Thanks, Prashant. So here is where we'll actually explore a little bit more about AutoRABIT and what do we have to offer. So next slide for me, Prashant. So let's talk a little bit about AutoRABIT and some of the best practices and really speak more towards how AutoRABIT integrates with Salesforce DX. So if we look at the top portion here, there's 3 different areas where AutoRABIT fits into the picture. First, we have, of course, Salesforce DX. We do integrate with Salesforce DX. That is our baseline. That is how we're able to offer within the UI to allow you to create scratch orgs or enable a dev hub, be able to specify really what is your org shape, be able to specify and your features and preferences, and also take care of merging, deployments, all of that good stuff. And that's really utilizing the existing capabilities that AutoRABIT already has to offer. And beyond that, we're also tying in ALM, and ALM could be something like a Jira or version 1, for example, really the solution that you're using to actually tie together each of your user stories and manage your user stories. And from there, we'll move on to feature branches. So a good part of Salesforce DX is really to really ensure that you're checking in all your code into your source control system. And part of that would be adopting a feature branch model. So essentially, you create a scratch org, for example, for your particular user story. You would also go ahead and create a branch for that user story. So you have your scratch org, you have your user story, and you also do have the particular branch. And that is your entire workspace for you to develop that particular user story. Once you're done, move on, create new environments, create new branches to move on to the next user story that you have. Now, there's some common best practices to really make this more efficient, and it falls under 3 different buckets. So the very first process is provisioning. Now, a scratch org is what you'll use when you're using Salesforce DX. Now, a scratch org doesn't have any custom code. It's going to be just your standard metadata components coming from Salesforce. So it doesn't have any of your custom apps or any customizations you've done on top of Sales Cloud or Service Cloud or anything of that sort is not available in that scratch org. So you'd have to provision that scratch org, which can be done through AutoRABIT. We can be able to go ahead and deploy any sort of metadata components that you'd like. You'll also be able to define your org shape. We can say, hey, I'm trying to build on top of Sales Cloud, as that is what my user story is allowing me to do. So I can go ahead and enable the Sales Cloud. And maybe on top of that, I need Einstein because that's something very important to me for my user story. I can enable Einstein as a feature or Wave Analytics, depending on what is your user story. So you're defining and provisioning your org shape by the particular scratch org and user story itself. Now, once your scratch org is set up with the perfect way that you'd like it to be in terms of your user story, it's time to start developing. Time to start making sure you're getting everything done as part of your user story, whether that's creating classes or objects or whatever it might be. And once your development is done, that's when this whole package-driven model comes into play. We'll package all of these components together for that particular user story and move it down the line, check it into version control, check it into your branches, and be able to ultimately release this into your production environment. So it's a complete cycle that all of this can be accomplished within AutoRABIT itself. Now, I know the common question in your mind would be, okay, that's all great, but where do I start? How can I get myself from my current model and move into more of this package-based model? Now, as Prashant alluded to earlier, this isn't a on and off type approach. We can't just turn off your current development cycle and model and just turn on the Salesforce DX and be able to think that packages and everything will work correctly. That's not the case. And as Prashant alluded to, again, Salesforce themselves know that this isn't something that will happen overnight. This could take 6 months, maybe even upwards of a year for you to get to the point of establishing a perfect process with a package-based development. Now, these are some common guidelines you can follow to really get yourself started. First and foremost, a blueprint around your monolith org and identify your application to see what are the applications that you currently have existing, make notes of that, make a list, make notes of all the customizations that you've done, really anything that's been done in your Salesforce systems, make a note of all of that so we know exactly what is available coming from your production environment in this case. And from there, we'll start to extrapolate some of these particular applications, some of the dependencies and so forth to create a base package, which will serve as just the application and all components that are needed so you can use that at a future date. Now, once you've created your base packages, and the packages themselves can be created based off of some of the schemas that were discussed earlier, be it feature-based, be it logic-based, be it different components when it comes to database or data usage and so forth that we talked about in earlier slides, those will be your initial guidelines to understand what are the metadata components I could put into a specific package. Now, what you would have to do is definitely your ALM or Jira solution or version 1, something like that is your best friend here. Also your Scrum Master to really identify what are the user stories that are available. And out of that, what can be modularized based off of the different practices that we outlined, based off of, is it a customization on top of Sales Cloud? Is it a whole separate application? Are we developing something on top of a particular managed package, for example? This will give you that level of detail. So you know exactly based off of the user stories, what can actually be modularized. From there, we'll identify the specific metadata components that you can modularize as part of packages using the patterns and anti-patterns that we've talked about just a couple of slides ago. Now, at this point, you'd be at the point where all your packages are ready. You've developed them, you've created them, everything is good to go from that point. Now you can establish the Salesforce DX model when it comes to scratch orgs. So as I mentioned earlier, scratch orgs are an empty slate. There's nothing that exists there. So the very first step is ensure that you define your org shape. And that org shape will be in turn defined by your user story. So as I mentioned earlier, if my user story was to develop on top of Sales Cloud, for example, I'll try to see, okay, what are the specific components that I need and specific features and preferences that I need to really define my scratch org. Now, once I've set up my scratch org based off of the specific org shape on that user story, I can start to look at what are my dependencies that I need for my particular development, and import any modules that I need in order to start my development itself. And this is what we call more of the smart package approach, because we'll set up the scratch org perfectly in such a way to where it's designed specifically for that particular user story. So there's no guesswork involved there. All you need to do is start developing, move that package along, spin up a new scratch org for the next user story. So here we have the AutoRABIT dependency analyzer. So this is something new that we are currently developing to really allow our customers to see, if I were to select an object, for example, what are the action overrides? What are the validation rules associated? What are the fields and workflow rules and so forth? Really, what are the particular dependencies where that object is referenced that I may need to pick up in order to really spin up my scratch org here? Of course, if I miss something, that may cause some either dependency issues or deployment issues, or I may not be able to actually start my development. So I need to make sure that I'm picking up everything that I need in order to move on to the next step of actually starting my development. So the dependency analyzer will allow you to really pick and choose and to see all dependencies on the list. So you can pick up everything in one go and even develop a package off of this particular deployment itself, which actually would lead me to the next point of org-specific templates. So based off of what you use as far as dependency analyzer, or you do deployments in AutoRABIT, you can create an org template. And this template can be used to set up your scratch org. It'll define your org shape. It'll also define what are the particular components that you need. So you can see on the screen over here, we have a sales template and we have a service cloud template, for example. These templates may have specific items, like maybe it has Einstein involved in it, maybe it has wave analytics. Maybe I need, to enable chatter notifications as a particular feature that I would have to use for my development. All of these specific items can be defined in that template as part of the dependency analyzer itself. So these two go hand in hand, and using this template, you'll be able to define your scratch org. And the best part is these templates are reusable and editable. So if something changes along the lines, click on edit, add any new components that you need, change anything that you like to change as part of that template, and save it again. And this can be used time and time again for as many scratch orgs as you like to, and you can have as many templates as you like to as well, making it a lot easier to just retrieve whatever you like, almost like a pull request, into your particular sandbox or your scratch org in this case.
So thank you, Abhi. So we spoke about how do we use, so how does AutoRABIT integrate with ALMs? How do you use ALMs to kind of create an intelligent approach to modularize your packages using version control, using Salesforce DX, but how does it all tie up? So this was a flow that we developed during the first initial days of DX, and we have kind of evolved it in order to fit into the 2GP model, or the second generation packaging model. So let's look at, so based on what Abhi just took us through, so there are three parts to any software development. One is provisioning, where the developer is provided with a environment or a sandbox or a play area where he would be able to develop or complete his user story. So taking that as a starting point, when you have your ALM user story, so if you have a request to create a feature, if a feature, let's call it F1, so the developer would go into the DevHub org and would create its scratch org. And at the same time, another branch would be created for him, indicating the feature branch, that would be right off the master. So now the feature branch has everything that has from your production, because ideally your master branches are normally looking at the production org, and you would use the dependency analyzer that we just saw in order to kind of modularize and pick up the components that you would require to complete this user story F1. So using the dependency analyzer, you'll pull all your components into your scratch arc. Once you impregnate your scratch arc with your base package, you will start your development process. Now, at the same time, the modules, the components that you picked up using the dependency analyzer can be extrapolated or transformed into the DX templates or the org specific templates that we just saw, so that they can be reusable across the application. So once you have your provisioning done, the developer would start working on his user story. So he already has his base package with his shared metadata members, which contains which is based on the patterns and anti-patterns of application decomposing. So on top of that, so he's going to create his own custom code or logic. So what AutoRABIT has also developed is, in order to achieve a perfect CI/CD nirvana state, it is important that we are able to control what is getting checked into your version control before it gets checked in. Now, there are multiple ways of doing it, but how do you get a workflow around it? And what we said, or what we put out as a visionary in this space, is once your feature one is ready, you would take it through a couple of sanity tests. Now, in Java language or .NET language, this could be unit tests, this could be PMD analysis. Now, the same thing, how do we apply into a Salesforce ecosystem? So you can validate the feature that you have developed onto your next environment or your logical higher orgs, and see if the package that you've developed will work or not. The second thing is running a static code analysis on your Apex classes and a few of your Apex triggers to understand if my code that I've developed, will it fit the industry standard methodology in terms of the violations? Like, for example, the variable names should not be too short, like variable A1, A2. We've all been there where we created variables on the fly, too many comments. So some of these things can be avoided to make sure that the compiling of the code is faster, and the Force.com platform is able to output your application, or is able to compile your code in a faster way, and is able to produce solid outputs. Next is the code coverage. This is a major problem that we all go through when we are developing Apex custom code, that when you create a Apex class in one of your environments, and when you migrate to the next environment, the code coverage generally fails because the footprints of both the environments are different. So how do you make sure that you avoid it? You make sure that you go through that sanity test of running the code coverage even before it is put into the version control. And then you can also have peer-to-peer code review, where one of your team leaders or one of the business members is validating the output and saying that, hey, this is what I exactly expected. So once the sanity gate is approved, and this is a manual approval process where a team leader or another peer should review his code and approve it for that code to be checked into the feature one branch. So from the scratch org, the developer has created completed his user story and is checking into this version control. Now, when he's checking into his version control, he would already be creating a DCP, or a developer control package, which is based off second generation packaging logic. And he would place that in a force app structure, or the DX folder structure in the feature one branch. So at the same time, you can update multiple areas. Like, you can update your ALM user story saying that the particular check-in is done, for the Scrum Master to know that a particular user story is now ready to move into QA or into the integration line. The chatter is updated so that all the stakeholders of that release are updated, saying that a particular developer has delivered on what he was supposed to do. So after the development process, there comes the release process, where you will merge your DCP code into your integration branch. So you simply merge your feature one branch into your integration line and move using the AutoRABIT CI server, install this package or upgrade this package into your next logical org. So this is where your enterprise practice kicks in, where you run your QA in terms of with the test automation or the regression testing or the functional testing or the manual testing will kick in, and the validity of the code that the user story demanded, has it been satisfied or not? So this is where the user comes in and says that, hey, I'm okay with it. So in the same line, you would move from your integration branch to your integration sandbox, to your QA sandbox, and finally you would move it into your production. So this is where the DCP would, the developer control package can be leveraged in order to install or upgrade applications in your production environment off the fly without depending upon a release schedule. So even if you want to pull back, a particular user story because business did not approve it at a UAT level, then you have that flexibility in order to move only the packages that have been approved into the next line. So dependency analyzer would be a major cut in order to make sure that your scratch arcs are populated with the data that you require, or the metadata that you require in order to complete your development. And in order to reuse, because that's the mantra that we are trying to follow, having reusability as a common design pattern to have as a solution to common problems. So that being said, this is where AutoRABIT is evolving into. So you can register your hub org, which is a production or business or a trial org, and you can scratch arc for the work items in this, create scratch arcs for the work items in your sprint based on your arc shape. Now, the scratch arcs can be created on the fly in AutoRABIT itself. You can open your scratch arcs. So basically, the developer, instead of installing the DX CLI, taking a checkout of his local version control, figuring out what's happening in the ALM system and so on and so forth, you can bring this entire silos of operations into one workspace that would be AutoRABIT. You can populate your scratch arcs with metadata from Sandbox or version control using the dependency analyzer and saving them using the module specific templates. Populate scratch arcs with the required data, create feature branches for your scratch arcs, log into scratch arcs directly from AutoRABIT, run static code analysis, merge changes directly between source control logs, perform pre and post deployment steps, and have a CI/CD process, a proper CI/CD process using the second generation packaging. So the best part here is the ability to repeat this whole entire process at a click of a button using AutoRABIT's intelligence that you would be getting off using the modularized Salesforce development. So I know we are almost about 10 minutes out into the meeting, but just to talk about where do we see the whole Salesforce DX and second generation packaging heading into. One, modular development would be taking the primary step. Salesforce would be pushing more and more into it. Developer control packages have already been announced as part of Spring 18. They're going GA with the Dreamforce 2018. So it is expected that the Salesforce community would also kind of jump into the river and flow with the river in order to adopt a more sustainable development model in the Salesforce transformational journey. So make sure that you're running automated unit tests, verify code coverage, static code analysis, security scans, code review with peers, produce high quality software. And at the end of the day, what business requires is a higher release velocity with absolutely 100% quality. So that brings us to the end of our presentation in terms of how do you go about your journey in adopting Salesforce DX and second generation packaging, and making sure that you're able to identify patterns in which you'd be able to decompose your current monolithic code base and adopt a more robust approach of development. So we're opening it up for Q&A. If you have any questions, please put them in the chat window and I'll be more than happy to answer.
Great. So there is a couple of questions actually that are in the chat, so I'll go ahead and start reading them here. So one of the questions that we have from Deborah is, are org-specific templates the same as Salesforce Sandbox templates, or would they work on dev sandboxes?
So great question. So these are different from the sandbox templates provided by Salesforce in a sense, but these would be reusable across a Scratch or a DevHub sandbox, or or a dev sandbox, irrespective of what the Salesforce environment is. These DX template, these art-specific templates can be reused.
Great. So we actually have two questions for Bertrand. Now, one of this was already answered in the chat, but I would like to reiterate it for everybody else on the call. So one of the questions here was, do I have to manually create the branch on my Git repository whenever utilizing AutoRABIT? And the answer to that is you don't need to. The branches can be created directly from AutoRABIT on the fly. We actually have a perfect workflow within our DX integration to allow you to either assign an existing branch, register one that you already have, or just create a new one directly from AutoRABIT itself. And another question from Bertrand is, what exactly are security scans, and can these be automated?
Yeah, so security scans could be the standard security scans available, like check marks or your Apex PMD or your SonarQube integrations, where you already have some security, some rules around your security. And yes, these can be automated as part of the AutoRABIT CI/CD process.
Great. So we have another follow-up question from Deborah here. So, do org templates let you know about duplicates and object in multiple templates, or would they help in building the 2GP structure?
That is correct. So org templates will allow you to kind of recreate the base packages and will help in introducing this base package into the Scratch org. So the whole idea of having a templatized version is so that you're quickly able to move your dependencies, quickly able to identify what are that shared schema that you need to have in order to complete a user story or in order to complete a development.
So we have another question on the chat from Alan. So it's more along the lines of licensing here. So how does the licensing work, or would each developer need an AutoRABIT user license and Salesforce licenses? So the way this would work is one of two ways here. So one, of course, the AutoRABIT user license is definitely necessary for this, as much of the features that we have as part of the DX integration especially would require the license of AutoRABIT, as utilizing the deployment features or checking in code and whatnot, our features are part of the traditional AutoRABIT. So we have 3 different licensing models that you can find on our website, and we could also get you in touch with our sales team in order to provide you a little bit more information as far as how the licensing would work with an AutoRABIT, especially when it comes with respect to Salesforce DX. Do you have anything else to add to that, Prashant?
I think that's perfect, Abhi. I see another question here. Salesforce suggests to commit modifications to a branch to DX, but the merge is done outside in the repository. How is merge handled in AutoRABIT DX? This is a wonderful question. So in the AutoRABIT backend, we are using DX tooling in order to move any kind of code from your Salesforce environment to your version control. And the benefit of using a tool like AutoRABIT is you can do your merges inside of the AutoRABIT. So we have seamlessly integrated with all version controls, let it be Git, TFS, SVN, Perfors, and you would be able to kind of use the merge functionality that we created. It's the world's first merge editor that is available, one of a kind, to move your feature branch into your integration line. So if you have any conflicts, you'd be given an option to choose if you want to manually resolve conflicts line by line, or if you want to directly choose from source or from destination. And you also have like a completely seamlessly integrated conflict resolution screen where you can choose the standard Git conflict resolutions, like using from source, from destination, mine before there, or there before mine. So we make it easy for the average Salesforce developer to kind of use merge without having to understand Git command language.
So maybe give one more minute here for any other final questions, and if not, we'll probably go ahead. We have some housekeeping things to conclude here. So we'll give one more minute here. Anybody else have any questions at all? Feel free to put it in the chat.
So while we're waiting, a recording will also be available pretty soon. We'll be publishing that on our AutoRABIT website and also on our YouTube channel, so that if you want to kind of go back and look at how do you adopt second generation packaging, because I think it's very important that all enterprises for Salesforce that are working on Salesforce need to move into this new age development model, because this is where it makes it easier for app development, for deployments to be repeatable, tracking changes effectively, and overall managing change in a brilliant way.
Great. So I don't think there's any more questions for right now, but if there is, of course, this recording will be there, and you could also email us as well, and we could definitely go and answer. Oh, looks like there's one question that just came in. So can AutoRABIT be ran from a CLI like DX? So the answer to that is AutoRABIT is not an actual CLI. So the whole idea behind this is we integrate with existing CLIs, we integrate with the Salesforce CLI, and in the back end, we're running those particular commands and scripts. And in the screen here, we just give you a particular button. So it's much easier for anyone to manage versus triggering items through a CLI itself. And with that, let's go ahead and move on here. You want to go to the next slide for me, Prashant? So the last couple of minutes here, we want to address two housekeeping items. So one of the items here is the acquisition of Salesforce acquiring, of course, MuleSoft. And this is something big for AutoRABIT, so kind of a free plug, if you will. So for years, we've been successful with Salesforce. We've already built a continuous integration and delivery solution for Salesforce itself. And in recent months, we've also been working with MuleSoft to develop a CI/CD solution for MuleSoft. Now, it just so happens that both of them are now together to where the possibilities are more endless for us. And we're quite excited about this acquisition, as we think it makes AutoRABIT a lot more powerful. And you really use existing context that we have in order to really bring out much better products, as well as advance our products much more than we already have, and really revolutionize what AutoRABIT has to stand for.
Yeah, so just to add on top of that, I'm really excited to see what AutoRABIT what Salesforce engineering would do with the whole MuleSoft integration. So we're talking about microservices, we're talking about micro-manageable containers. So there's a whole new world awaiting, and this would be more good news for Salesforce developers. I've got another question here. How long do you think it will take for development on Salesforce to be on par with development that happens on, say, Java or C#? Well, this is kind of tricky. So I think the Salesforce development is already on par with a Java or a C# when it comes to having a cloud-based multi-tenant environment where you are having perfect cloud computing and you're able to compile your applications faster, provide to multiple business users around the world at the same time without any lag. I think the development is already on par, or rather ahead, because ideally Salesforce is built on Java. So I hope that answers your question.
Great. And one last item before we wrap this up here is Trailer DX is next week. So we really hope to see some of you there. So you can visit us at booth number 18. Myself will be there, and we'll also have some other members from our teams joining us at the booth. So if you have any further questions on this webinar or Salesforce DX or really the AutoRABIT solution as a whole, feel free to stop by our booth. Again, it's booth number 18. And we look forward to meeting some of you there next week. And we also do have some sessions going on. So you can visit our website to see what are our sessions that AutoRABIT will be performing. And we're also taking part of the demo jam that's there as well. So if you're interested in seeing a mini demo of what AutoRABIT has to offer, I will be sure to show up for that as well.
So I see one final question from Kevin Lambert. How does AutoRABIT manage scratch or provisioning when necessary dependencies are required, like installing a series of managed packages and performing post-deployment steps that need to be automated? So a very good question again. So when we're creating scratch arcs and when you're trying to move your base package into your scratch arc, the dependencies would be identified by the dependent analyzer, and anything that is not available for the metadata API, you would be able to create templates inside of what we call as our provisioning module in order to kind of automate this entire chain of events. So you'd be creating a step-by-step procedure, and this is what the org-specific templates would do. It's just not about metadata, it's about creating that holistic interface in the scratch arc right from what you need for what you need to develop.
And with that, we thank all of you for attending this webinar. So if you want to learn more, feel free to shoot us an email at info@autorabit.com. You'll also be getting the recording of this particular webinar here in the next few days. So definitely keep an eye out for that. And again, we're also at Tail at DX. If you definitely want some more information, you could also speak to us and one of our experts at the booth itself. So again, thank you very much for coming, and we'll see you at the next one.
Thank you, guys.